LED to blink. Okay, so now you can just look into the camera. I'll go to the camera now. So I need to switch. Okay, you can see the camera. So I have IO terminals here, right? Let me move this here. I have a breadboard. I hope you can see now. Okay, I have a breadboard here. Let me take an LED. LED has cathode and anode. Okay, so I'm going to place my cathode and anode here on the LED. Okay, on the breadboard. I'm going to make this to blink now, and I'm going to make it as a standalone system also. Okay, right? So I need two wires to connect the anode and cathode. Okay, of the LED. This is the okay. This part is the anode part. Let me connect it here. Okay, and to connect the cathode to the ground terminal, I need another wire. Let me give the connection. I think you people can see the connection also. Okay, that's why I just turned on the camera. Connected. Okay, we'll go for a live demo. Just give me 1 minute. Let me take the screwdriver. I need a screw terminal. Thank you. I'm back now. Let me give the connections. So I'm going to use DIO 0. Okay, let me use the digital pin DIO 0, and then connection is done. Next step, digital ground. I'm giving the connection. That. Okay, connection is done. So now we are going to make this LED to blink. Okay, so I hope people have seen the connection now. Then I'll move to the logics. Yeah, so see, I have one button which is I'm using onboard LED. Now I'm going to use a digital input output. So go to my IDEO, and whenever you're going to send a command from your system to your hardware, okay, sensor, it's D out, digital out. So let me select digital out, and I'm going to place it here. Okay, once I place the digital out here, so you have to select the which digital input output pin we have used. So I have used the C port DIO 0. See, this is a place where you can just configure your channels. So expand, it comes under C port DIO 0. Okay, you can just give LED blinking. Okay, and I'm going to use only one LED. Let me provide OK. And now we have to develop a small logic to blink. Okay, and the most important thing, when we use loop, we have to use a delay function in order to reduce your CPU performance. Let me provide 100 millisecond delay, and then we have to develop a logic to make your LED to turn on and turn off. Okay, to do that in a very simplest way. Okay, so what I'm going to do, we know this I value. Okay, this I value is going to give, it is going to give how much number of times your loop has been executed, and always it starts from 0. Okay, so I'm going to develop a small logic by using quotient and reminder. Maybe you can increment by 1 because I starts from 0. If you want, you can increment this with 1 initially. Divide by 2. Okay. And when the demand is equal to 0, it's going to give true value. I'm going to go for comparison palette. There is an option called equal to 0. Okay. Connect it. We know the comparison output will be always true or false. And this is nothing but your quotient and reminder function, which is present in the numeric palette. Okay. And this is your increment operator. Fine. And this will be given here. That's all. Our logic is done. To make your LED to turn on and turn off, your logic is over here. Okay. We'll run, we'll deploy, we'll check whether it is working properly. And save the code. It is deployed. Okay. And now we'll go to the camera. We'll check. See the code. It's running. I have to check with the LED. Digital ground. It's connected. And let me check the button first. Okay, button is working. Then I have to check with the LED. Let me change the LED and check it once. So DIO 0 C4. Let's stop this. It has to blink. I have to check with the channel then. The connection. Maybe I'll change the terminals here. Check it once. I'll stop the code. Check the Rio is connected. Yes, it is connected. And I'll go with the okay. So okay, I have just selected the wrong pin, so that's why it does not work properly. So before I selected DIO 1, so actually I have connected DIO 0. Okay, Control B. So yeah, now I'll run the code. We can see the LED blinking. So I've given a wrong connection. Yeah, I hope you people can look the screen. The LED is blinking. Okay, see, it's keep on blinking. At the same time, when I press the button, where is the button? Yeah, see, the LED is also blinking. So we have just made two logics, and now we are going to make this application as a standalone system. Okay, so how to make this application as a standalone system? So that is the next step which we are going to do now. Okay, I'll go to the VI. I'll stop the program. Okay, and now we'll make this system as a standalone system. Okay, fine. Yeah, so we'll do that. So now I'll go to the project screen. Okay, so this is a project screen. Fine. So in this project screen, to develop this as a standalone system, so what you have to do is you have to first save the project file. I'll save the project. Okay, so desktop WC Anshmir. Okay, I'll make it as a demo project. Okay, demo. It is saved now. Okay, to develop a standalone system, first you can see there is an option called build specification. Okay, there is an option called, see, there are two build specification. One is under my computer, another one is under Rio. As we're going to develop a standalone system, go for build specification under my Rio. Right click, new, real time application. You have to select an option called real time application. Once you select this option, okay, so we'll get a pop-up. It takes little bit time. Okay, see, I have this is the pop-up next you'll get here. In this you can see there is an option called there is a menu called category. Under this category menu you have to select an option called source. This gives you the information about your standalone application, and just select source file. Okay, and this is the VI which we are going to make as a standalone system. So once you select this, you can see an arrow mark is enabled. Select it, the copy will be page of the VI will be pasted in the startup VI, and then look, there is an option called build. Okay, click on the option build, and now it will try to start, or it will try to build your standalone system. Okay, it's building a see, compiling, it's building a standalone system. Okay, so now yes, it is done. See, the build is complete. You can locate the build at the respective place. Okay, fine. So now the next step is you can just click on done. Your standalone application is created. Next, whenever your view gets powered, okay, whenever your view gets powered, automatically you want this application to run by its own. So for that, right click on the real-time application. There is an option called set as startup. Okay, so when you select it as set as startup, whenever your view gets powered, automatically this application will start to run. And next one, right click, and there is an option called run as startup. When you select this run as startup, see, your code will get deployed. It will say your Rio must be rebooted to launch the application. You have to select yes. Okay, once you select yes, kindly look here. Okay, got an option. What happened? There is an error. So run as startup. It's deploying now. Yes. So there is an error to build the real-time system. Okay, it is deployed. Proceed with reboot. Yes. I think there is some library issue in my system. It's not showing as a standalone application now. Okay, let it be. So we'll try to build an IoT based system now, because that is a target which we have to do. Fine. So I think that due to some library function, it is not booting properly. So we'll try to develop an IoT based system now. Okay. So now, whenever you want to build, okay, so whenever you want to build an IoT-based applications here, so you have to go for wireless data transfer, okay. So because we are going to use internet as a medium, to transfer the data, okay, right? To share, we are going to share the information by using internet as a medium, right? So we'll go for IoT based application, and now we need to change this into a wireless based communication. Okay, so where we're going to use internet to have the data transfer. Okay, we'll be using internet to have a data transfer. Okay, so now we'll move into the IoT part. Okay, yes. So first, we are into the IoT tech part now. The first thing here is, okay, so if you want to make an IoT based system, right? So from where this IoT has been evolved, okay, we have a small few discussion and then we'll move into the IoT part. Okay, so from where we have got this Internet of Things. Okay, so Internet of Things has been evolved from Internet of People. Simple. Before, okay, so when before things started to communicate, right? So we used internet for what? So we used internet, okay, for data transfer. Okay, we use internet to share the information from one people to another people. Okay, the best example for IoT is what? Now we are under pandemic, where everything has been come into online. Even if people are handling the sessions through internet, where interacting with the people or with the students through internet. And now we are conducting an FDP program where people from all around India are participating in this program. So you all are at different places, but we are all communicating together by using this internet as a medium. Okay, so Internet of Things has been evolved from Internet of People, where people started to use internet to share the information like downloading or uploading the songs, or to scan and send any images. Okay, fine. Or if you want to go for a live streaming and all, it is possible by using internet as a medium. Okay, so this is how people started to share the information, or people try to communicate between each other by using internet as a medium. Okay, next thing, how Internet of Things comes into picture. Things are nothing but the long non-living beings. Okay, so where the things has a capability, whenever these kind of things has a capability to transfer or to have a data transfer, okay, between each other through internet as a medium, right? There Internet of Things comes into picture, where things started to communicate among each other by using internet as a medium. Okay, fine. Where IoT comes into picture here. Fine. So we know before we'll have analog sensors, then we move into digital sensors. Now everything, we have another option called smart sensors, where the sensors have a capability to interface. Okay, where it has a capability to transfer the data from among each others. Okay, by using internet as a medium. Fine. Okay, so this is how your Internet of Things has been comes into picture. Okay, so why we'll go for IoT? Okay, it's going to provide a better scope, okay, for the data scientists, and we have a lot of career opportunities where you can go for real-time analysis, where you go for industry-wide connectivity. Fine. So whenever we go for IoT, okay, so we have to use some hardware for the IoT, okay, to make Internet of Things, like sensors. Okay, we need sensors and we need devices. Okay, we need devices, general devices, and then we need what? Sensing devices. Sensing devices are nothing but sensors which is used to sense the parameter. Okay, and what are the general devices? Okay, the devices like embedded device. Okay, embedded processor, where you can just develop a logic to read and write the information from the sensors, and you can just incorporate the IoT functionalities also in order to have a data transfer. And next one is what? Connectivity for the platform. Which platform we are going to show for connectivity? Okay, it can be a wired communication or it can be a wireless communication. Okay, fine. So we can go for networking, where you can just go for a lot of devices to connect. Okay, and then you can have a data transfer. Okay, fine. So we need hardware, at the same time we need what? Softwares also. Fine. So simple example, when smart automation comes into picture, we'll go for home appliances. Everything can be communicated among each other. Okay, and they're controlled by the sensors. Okay, so each sensors which would be used to help and to solve the problems. Okay, fine. So when things has a capability to sense and communicate, okay, things are nothing but the sensor. When it has a capability to sense, okay, to measure some parameter, and if it has an option to communicate, okay, by using internet as a medium, right, we can achieve Internet of Things here. Okay, fine. So this is how we can achieve the Internet of Things. A small example, humans. Okay, so humans, we have brain. Our brain is nothing but a controller where we can get the information from these the sensors are nothing but the sensing organs of the human. Eye, which is used to visualize, nose, which is used to smell, tongue we have to taste. Okay, here we have ears for hearing. Okay, so these are the different sensors which we have where it gives passes the information to the brain. The brain is nothing but like an embedded processor or a controller where decision will be taken and we can do some action. Okay, fine. So this is how human works. But when devices comes into picture, how we can build an IoT based system. Okay, fine. Simple example, now you have telephones where you have a lot of applications there to transfer the information through internet as a medium, and now we know we have some wristbands where we have an option to measure the heartbeat, okay, beats per minute, and you can measure your blood pressure, okay, and you can measure how much distance you have walked for a day, and if it has an option to transfer, if it is a smart watch, right, if you can just transfer the information to the doctor where you can have like a health monitoring systems over there. Okay, so this is how the things started to sense, and how you can build an individual IoT devices. Okay, how we can build the individual IoT devices whenever we have sensors. Okay, so sensors are used for measuring the physical parameters. Okay, and those sensors are connected to the controlling unit. Okay, what is a control unit? Either it may be FPGA based system, or it may be embedded processor, or it may be a microcontroller, or even Arduino, Raspberry Pi, whatever it may be. Those are nothing but your control units. Okay, and obviously the control units are what? Electronic devices. It needs power. Okay, it needs power to work, right? So you can just we need battery, or you can have some power supply to provide the power to the control unit. And next one, communication medium. Okay, either you can communicate with Ethernet, or you can go with USB, and if you're going for wireless based communication, okay, and we'll be using internet as a medium to share the data, it all together forms an IoT device. Okay, fine. So next one, so how we can form network of IoT devices? Well, each and every IoT device, okay, has an option to share the data through internet, where you can form a network of IoT devices using internet of medium. Each and every IoT device can share the information with one another. Okay, in the network. Fine. So these forms your networks of IoT devices. Okay. So if you look here, this is what I say. So we need gentle sensing devices. Okay, devices to sense the information, and we need a processor to sense, to take some action. And the connection media, it may be either Wi-Fi or wireless wired mode to transfer the data. Sensing devices are used to sense the information like light, temperature, okay, flow, right, and humidity, whatever it may be. You can make use of such sensors here. Okay, so to have a smart automation system, like smart home automation system, where you can just monitor all the parameters of the machineries in the home using your phone, and you can control it also. Okay, fine. So, and when industry comes into picture, we forms an industrial automation systems. Okay, so when you look here, the actuator, we have sensors, we have control centers, we have machines and actuators. So actuators, it's going to work like an interface between a sensor and a machine here. Okay, it collects various information, okay, like humidity, temperature, light density, whatever it may be, and the information is computed using edge layer. Okay, fine, it's computed, and it's between, okay, you can see the edge layer is between the cloud and the sensor over there. Fine. So, and what you can do, so the edge layers, okay, these are the layers which is used to store the intermediate information and transfers the informations over there. Okay, and all the backends will be taken care by the cloud. We know cloud is nothing but your virtual memory here. Okay, fine. So this all forms an IoT platform, and you can see here these are the different layers. Okay, these are the different layers. We have devices. Next, connectivity comes into picture, and the third one is going to be the device management platform, and the fourth one is going to be the application layer. Okay, so if you see here, the device management platform, okay, it is going to interact between the software layer. Okay, it's going to interact with the software layer, so through the network gateways. Okay, through the network gateway. So what exactly this device management perform? platform will function. Okay, it may be used for firmware upgrade, it may be used for security patching, it may be used for alert mechanism. Okay, and you can see here we have a connectivity block. Okay, so we will be using a common protocol. So connectivity is nothing but the backend. Okay, the backend for the IoT based application, which will help us to share the information. Okay, so we have actually various connectivity layers over there. Fine. If you see here, we can go for USB based communication, you can go for Modbus based protocol to have a data transfer, you can go for CAN protocol, or if you want to go for wireless based connectivity, you can go for Wi-Fi, you can go for LoRa, okay, you can go for Zigbee. Okay, so you can interface with any application or with any modules. Okay, or with any small devices embedded in the objects over there. Okay, so this is what we call as actually gateway architectures. Okay, fine. So this is the information about these application layer, device management layer and all. Okay, so we have industrial IoT, we have commercial IoT. Commercial IoT is nothing but consumer Internet of Things, which is used for smart automation system in home and all. When industry comes into picture, so this is used for health monitoring system of a machine, and you can go for conditional monitoring system. Okay, and if you want to have a data transfer, so you can have a data transfer through internet as a medium. Like people no need to go near to the machine to get the data. So once it is has option to interact with internet, right? So you can just visualize, or you can receive, or you can collect all the information through internet as a medium. Okay, fine. And mainly it is used for health monitoring system, where you can avoid the downtime in the manufacturing industry, which is going to impact on the production part. Okay, fine. So this is how your industrial IoT works here. So this is the revolution of industry, like from industry 1.0 to industry 4. In industry 1.0, so they used mechanization and steam power. Okay, and when you look into industry 2, where we started to use the conveyor belts and all to transfer the product from one point to another point, which reduces the human effort. Okay, and we started to use electrical energy in the industry. Okay, fine. And if you look into the industry 3.0, where automation comes into picture, computers and electronics, where without it reduces the human effort, where the machine itself started to do the task by its own when we deploy the logics on the respective controller, where automation comes into picture. And now we are in industry 4.0, where cyber physical systems, internet of things and networking comes into picture, where each and every machine started to communicate among each other by using internet as a medium. Okay, so this is the industry revolution. This is the industry revolution from industry 1.0 to industry 4.0. Okay, so with this is a small information or the introduction about the internet of things, as you people are already working more on the theoretical concepts, right? So we can directly go for an hands-on demonstration. Okay, so how we can achieve this internet of things. Okay, so first thing I'm going to explain how we are going to have a data transfer in wireless mode. Okay, how we are going to have a data transfer through wireless using internet as a medium. Okay, so I'm going to read and deploy the code using Wi-Fi. Okay, so all the communication will be done with the Wi-Fi mode. Next one, how we can transfer the data. Okay, how we can transfer the data, okay, from one system and another system when all are connected in the local network. Okay, fine. And first we'll see how we can go for a wireless data transfer. Next we will come to this, how we can have a data transfer when systems are connected in a local network. Okay, fine. So we'll move to the demo part now. So I'll go to NI Max. Okay, so this is a place where you have to go for Wi-Fi based configuration. Okay, so now I'm going to connect my Rio through Wi-Fi. See, still it is connected in wired mode, right? I'll go for my Rio. Okay, and I'll go for network setting. See, there's an option called disable. I'll select connect to wireless network. Okay, so when I select connect to wireless network, okay, I'll expand this wireless network. See, it is showing different Wi-Fi options here. I'm going to use my mobile hotspot. Let me select this. So I have to provide my password. Okay, and configuration, it should be DHCP only. And now I need to save the settings. Okay, when I save this settings, you can look the camera 3. Okay, see now my Wi-Fi LED, you can see this is my Wi-Fi LED, the third one. Okay, this one Wi-Fi LED glows in blue color, which means that my device is communicating through Wi-Fi now. And if I select this MyRio hardware, okay, and the IP address when my device is connected in Wi-Fi, it's 192.168.43.211. Okay, so now see, I'm going to remove the. Okay, let me show in camera. That grabbing. See, I'm going to remove the USB connection with my system. Okay, first step connection is done. Only it is powered. So hereafter, I'm going to have a data transfer with my. I'll put like this so that we not have the glare. Let it be like this. Yeah, the system is visible now. See, I've removed the USB. Okay, yeah, only it's powered. If you have doubt, you can see only Mario is getting power. Apart from that, there is no connection over there. So now we'll move to the coding part. See, it is disconnected now. So I have to change the IP. So it's 192.168.40. Let me check. 43.211. Okay. 43.211. I'm going to give OK. Okay, it's not responding. It will take few minutes. It's loading. Yeah, it is done. And now I'm going to connect. See, it's connected now. Okay, hereafter I can read and write. I can dump the code using Wi-Fi. Now you can see the same code. Okay, I think I'll minimize this so that you can see both parallelly in the camera. Okay, you can see here. Let me run the code. Okay, saving it, deploying. Okay, you can see here, grab, see, LED is blinking. Now I'm having the data transfer through Wi-Fi. Okay, now USB cable is connected, so you can read and write the data using your Wi-Fi mode. Okay, so this is how you can connect your existing device with your internet, and you can have a data transfer. Okay, through this Wi-Fi. And next step is what we are going to learn, how we can have a data transfer. Okay, and even if you want to check, just hold it properly and press the push button. See, the LED is getting turned on and turned off. Okay, next step is what, if you want to stop the code, see, stop, the application has been stopped. Okay, fine. So now we have just made a data transfer through Wi-Fi. Okay, next step, so how we are going to have a data transfer between two different targets. Okay, when they are connected on the same local network. Okay, when they have connected on the same local network. So that's the concept which we are going to discuss. So defining the local network here. Okay, so here if you see, these are the things we have seen: edge device, we have connectivity, we have back end, front end, and mobile. Okay, so what we are going to do here is we are going to use local network plus gateway, okay, to have a data transfer. So here I am going to use Wi-Fi as a connectivity medium to have a data transfer here, okay. So whenever if you want to transfer the data between two devices of same network, okay, and if the devices has LabVIEW target, okay, if the devices have LabVIEW targets, you can go for shared variables, or else you can go for network streams to have a data transfer between two systems. In case if the devices are non-LabVIEW targets, where one system has LabVIEW and another system doesn't have LabVIEW, but even if you want to have a data transfer between two systems, you can go for TCP/IP protocol, or else you can go for UDP protocol. Okay, so you can make use of any one of these protocol to have a data transfer between two non-LabVIEW targets here. Fine. And if you look, so here I'm going to use shared variable. Okay, so you can see here I'm going to use a shared variable to have a data transfer. Okay, to have a data transfer between two targets which is having LabVIEW. Okay, so in order to explain how we can transfer the data using shared variable, I'm going to show a small demo where I'm going to transfer. Okay, I'm going to read and write. Okay, I'm going to read and write the data from my mobile phone to Rio hardware by using internet as a medium. Okay, internet as a medium, and by using shared variables. So I'm going to transfer the data between two different targets of same network. Okay, in order to demonstrate this application, I'm going to use, okay, shared variables. Fine. And once we done this application, we'll see how we can go for passive cloud, how we can access the clouds in order to have the data transfer. Okay, so now I'll go to the logics part. You can see here, let me save this code. It is saved. I'm going to close this. Okay, I'm going to create a new VI. Right click, new VI. Okay, so what I'm going to do here is, so I'm going to interface. Okay, I'm going to interface a sensor. Okay, I'm going to interface a biomedical vernier sensor, which is used for measuring the grip strength and the pinch strength of the person. Okay, fine. And if you want to look that a sensor here, I think it's grabbing now. Yeah. See, this is the sensor which I have. I have to, let me change focus this camera this side. You can see. Okay, so this is the sensor which is called hand dynamometer. You can see in the camera. I just keep here. Yeah. See, this is called hand dynamometer, which is used to measure the grip strength and the pinch strength. Okay, grip strength and the pinch strength of a person. So same, we have vernier ECG and the blood pressure sensor. So which I cannot use by myself because the patient should not be in a mobile state when we try to measure the parameter. But I can use this my alone. Okay, to acquire the information from the sensor. So I'm going to use this hand dynamometer to measure the grip strength and the pinch strength. The output will be in terms of voltage. In order to convert this into a kilogram, okay, in order to convert this into Newton, kilogram, or pounds, so we have to do a small calculation, y equal to mx plus c, okay, so that we can convert your voltage value into the respective physical parameters. Okay, so let me give the connections for this hardware. Okay, so I have to give the connection. So for this I need to use a BTA connector. Okay, so that I can have a data transfer. Okay, so this is what we called as BTA connector. Through this pinouts only, I can just give the connections to my hardware. So I need a 5-pin connector. So let me give the connection. So this is the sensor which I'm going to measure the parameters. Okay, and to give the connections, I need to go with the data sheet. Data sheets biomedical. It's the BTA connector. Okay, so I have to based upon the pin connections only, I need to give the connections now. So let me use this IDEO hardware to give the connection. So if you want to see the connections also, I can provide now. Let me keep this here. Okay, so pin number 6 is for sensor output. So this is yellow, pin number 6, which I'm going to connect through analog input terminal AI 0 plus. Okay, and AI 0 minus will be connected to analog ground. Okay, it should be connected to analog ground here, and it needs a power supply. So this is connected. Next one. So pin number 2 is for ground, and the black color is your pin number 2, which is for ground now. Okay, and do along with this to turn on and turn off the LED also I need a ground connection. So I'll maintain these two. Yeah. Okay, and then it needs a power. Pin number 5. Pin number 5 is the orange wire, which needs a 5-volt power. So let me give the connection. Yeah. Yes, though the connections are ready. Okay, so for the sensor, and I'm going to show two demos together by sharing the analog data and the digital data. One is for LED, another one is for the biomedical sensors. Okay, so we are going to work with two family, analog and digital. Okay, so LED, now it is on. So I'm going to control this on and off of the LED through my mobile phone. Okay, I'm not going to develop any logics in my VI. I'll be controlling this through my mobile phone. Okay, so now you can ask like what is BTA connector. Actually the sensor pinout will be in this term, which cannot be directly interfaced with the Rio hardware. So we'll be using a small BTA connector which are shown in the camera. So this is the British Telecom analog connector. This is the pin terminals we have. So as we need power, we are going to give 5-volt power supply from the Rio itself, because we know we have 5-volt power here. And then we're going to measure the output from pin number 6. Okay, and pin number 2 is for ground connection. And this is the sensor which I'm used for this hands-on demo. See, this is an hand dynamometer. Okay, so which is used to measure the grip strength, pin strength of the person. Okay, so you can develop a small application like whenever the person you can just collect the data. Okay, it is like collecting the data from different persons by making them to give a pressure. You can just note down the values, age, okay, and the gender. So you can just develop a small logics like whenever a person just comes and apply pressure or force on the hand dynamometer, you can just tell them the age range of the respective person, okay, and you can detect the muscle fatigue. See, you can just mention, you can just compare the hand grip muscle fatigue rates also, okay, and you can convert these values into Newton, pounds, and kilogram, okay. So for this conversion, so you can see you can measure the grip strength and you can measure the pinch strength also. Fine. So this sensor has the capability to interface with NI hardware, and you can make use of LabVIEW software to acquire the data. So in the same way only, we have vernier ECG sensor, we have vernier blood pressure sensors, okay, where you can acquire the information. And here, to convert the values, okay, to convert the measured voltage values, okay, into an kilogram or pound, we need to go for a straight line equation, y equal to mx plus c. Okay, so when we go for y equal to mx plus c, see, we have given in terms of Newton, you can make use of this m slope, c intercept. In terms of kilogram, you can make use of this slope and intercept. In terms of pound also, you can make use of it. So I'm going to use this sensor to interface, and then we're going to get the data. Okay, fine. So this is the data sheet of the hand dynamometer. So next step is what we have to develop the logics here. Okay, we have to develop the logics. So the Rio demo, I'll close it now. Fine. So now we have to run the program continuously. We need to use what? While loop here. So I'll place a loop, create, control, and then we know we have to create a delay function, wait ms, create constant 100 millisecond delay. Okay, and first I'll show how to measure this information from the hand dynamometer. So it comes under analog. So go to the MyRio palette, analog input, place it here. You have to select the pin. It is from C analog input AI0. Okay, we can just mention it as hand dynamometer value. Okay, and if you provide OK, and this is configured to provide your hand dynamometer values here. Okay, now if you want to see the result, okay, if you want to see the result in terms of graph, let me show it in the LabVIEW now, and then I'll show how to transfer the data through to the mobile. Okay, let me connect it here. Fine, and this output will be in terms of voltage. So right click, even in wave here also, we can just display, sorry, you can display the digital values here. Okay, so you can read the digital value, and we know the output will be in terms of voltage now. Okay, to convert that, to convert into the kilogram or into the pound, we need to go for y equal to mx plus c. So m value into c, mx plus c, this is your x, and this will be your m value. So in the data sheet, to convert it into kilogram, m value is 17.8875. I'll go here, 17.8875, and then plus c, numeric palette, addition function, c. Okay, c value is minus 1.9676, and we can enter here minus 1.7696. Okay, so we have entered an indicator. Okay, indicator will be in terms of kilogram. Numeric, if you want, you can go for meter. This is also a small type of indicator which will provide you in terms of kilogram, and it is like a graphical representation. That's all. Okay, I'll keep the stop button here. I'll keep the meter here. Okay, let me provide 50 kg. Okay, you can just place it here. Fine. So now we can run the code. It will ask us to save the VI. So it's and dynamometer, the VI save, and it is now transferring through Wi-Fi. It's not through wired mode. See, it is showing 20. So let me apply a pressure, which you can see through the camera. So I open the cam. You can see here, and this is the front panel. I'll just keep it. Okay, you can see both. So I'm going to just press this. Okay. Pin number 6. Okay. One small connection change I need to make. This is a small connection change. So pin number 6 is your analog input. Okay. Let me do this here properly. Okay, sorry, again this removed. So pin number 6 is given, and pin number 5 is for power supply. And pin number 2 is for ground. So I'll give the connection. Yes. So now, if you see, I'm going to apply a pinch. You can see the voltage. So when I apply a grip, okay, so I need to connect. I'm not connected the indicator here. That's why it is not showing in kilogram. Okay. So we'll run this now. Okay. See, when I apply the pressure on the hand dynamometer, you can just see in the camera. Okay, see, I'm going to give a pinch. See, for each and every pinch, I'm getting a spike. And if I'm just going to keep on apply the pressure, see, when I just apply the pressure, it is converting into kilogram. Now I applied a 5 kilogram pressure, and if you want, if I just hold it, apply more, I can apply up to 20 kilogram pressure. Okay, so this is how I have just connected my hand dynamometer, and I've converted my grip strength into a kilogram, and we are transferring the data through internet, and I'm looking in LabVIEW application. So next step, how I'm going to watch these information in mobile phone. Okay, so instead of looking into LabVIEW screen, I'm going to see this information in mobile phone, and to turn on and turn off the LED also, I'm going to control the on and off LED through my mobile here. Okay, see, in my front panel, as of now I don't have any control here. Okay, so let me introduce shared variable to you now. So right click on the MyRio hardware, new, there is an option called variable. Okay, now I'm going to add a shared variable now. Okay, so I'm going to see this hand dynamometer data in my mobile phone. So let me select this. I'm going to give hand dynamometer. Okay, and it's going to be a BBL data. A shared variable is created now, and to turn on and turn off the LED, I'm going to add a variable. Okay, so LED. Okay, and it belongs to Boolean family. Select Boolean, provide OK. So now two shared variables are added here. Just select, drag and drop it in the block diagram. Okay, yes. So I have an LED. See this hand dynamometer value. I'm going to change to write mode, where I'll be looking the value in my mobile phone, how much kg pressure I have applied, and the LED I'm going to turn on and turn off. It's connected to DIO, digital out, 0th pin. Okay, so C port DIO 0. Okay, I'm going to provide OK, and I'm going to connect here. Fine, and then you have to deploy the program. Okay, so I'm going to deploy the program. It is asking to share the shared variable. I'm going to save this as WEC variable. Okay, and it is saved, it is deployed, and now I'm going to configure in my mobile phone. When it gets closed, so it is, I see the I'll just go to the camera now. I'll just keep my phone in front of the screen. Okay, kindly look here. It's visible. I'm going to select an app called Data Dashboard Application. It belongs to National Instrument. How to focus this? It's too. Let me keep it here and check. Yeah, I think yes, it is visible now. Perfect. Okay. I think, yeah, now it's fine. See, I'm going to create a VI now. Select. Okay. One indicator and one control. So one indicator, it is to see the value which we're applying from hand dynamometer. If you want to see in gauge, you can give, or if you want to see as a numeric indicator, you can give numeric indicator. Select it and put it in the front panel. Okay, right? And another one, we want to turn on and turn off the LED. So I'll go for control. I'll go for switch. I'll put it here. Okay. So now we need to configure this switch and the numeric indicator. I'll just click here. See, shared variable. You have to enter the IP address, and this is the IP address. Okay, and see, WEC variable is the shared variable name. I have selected the shared variable and LED. It is configured. Next, the numeric indicator. Fine. So configure shared variable, IP address, and hand dynamometer. Now it is configured. I am going to run. Okay. When I run this code, sorry, I'll just arrange it. You can see the LED also. See, the LED is not turned on. I'm going to switch here. See the LED in this. I think you can look in the screen now. When I just turn on and turn off the LED in, give the command in mobile, the LED is getting turned on and turned off. And to read the value, I think it's clear now. Yeah. See, hand dynamometer. I'm going to apply force. See, you can see it is converting into kilogram. It is now 7.5. Okay, so this is how you can have a data transfer between between two targets of local network. Okay, using network shared variables. See, I can turn on and I can turn off my LED also. Okay, so this is how you can go for use of network shared variable. To stop this, you can just stop. Okay, the program will stop here to start and receive the command. Okay, see, this is a small demo how I can go for a data dashboard application. Okay, which is comes under NI, where we can have the data transfer. using network shared variables, okay, between two systems of when it is connected to same local network. I hope you people have come across a word called local variables and global variables, right? So local variables are used to pass the value in the same VI. When you want to transfer the data between two different VIs, we'll go for global variables. And if you want to have a data transfer between two targets, we will go for network shared variable. Okay. So this is one demo how we can go for the data transfer between two different targets of same network. Okay. So I hope this VI gives you a better idea how we can transfer the data using the shared variables. Okay, next thing I'm going to show another demo how we can access the passive cloud in order to have a data transfer. Now we are going to push the data from LabVIEW to cloud now. Okay, right? So if you look here in this slide, so if you want to have a passive cloud, okay, so we will be using clouds, which is a virtual memory, which is going to act like a backend here. Okay, so there are different types of protocol which supports for IoT connectivity. Fine, you can have device to device transfer, okay, or you can have device to server transfer, or you can have server to server transfer, and different protocols which supports HTTP, hypertext transfer protocol, and another one is secure HTTP. You can go for WebSocket, you can go for DDS, message queue telemetry transport MQTT protocol. You can go for AMQP protocol also. Okay, so very simple way. I'm going to use an HTTP protocol in order to have a data transfer. Okay, to the cloud. So there are different types of cloud which LabVIEW supports. You can go for AWS, Google, IBM, Bluemix, etc. ThinkWorks. Okay, right? So AWS and all you need to pay and get the access. The easiest way to show a demo and you people can also take a hands-on later. You can go for Google. We'll go for Google Cloud. Okay. So for that it supports HTTP protocol, which all these functions will be available whenever you install the LabVIEW software. Okay, so I'm going to use a cloud called Google Firebase Cloud in order to have a data transfer, and it supports HTTP protocol, and the cloud name is Firebase. Okay, so now we are going for a cloud connectivity demo. Okay, so let us use the same logics. Okay, let us use the same logics. I'm going to create another VI to have a data transfer, but I'm not going to use shared variable. Instead of using a shared variable, I'm going to use what? Okay, so I'm going to use cloud. Okay, Firebase cloud here. Fine. So I'll close this VI, or else I can just copy this content. Okay, let's see this. I'll close. I'll create another VI. Okay, so where I'm going to transfer, okay, where I'm going to transfer this hand dynamometer data to the cloud. Okay, or else if you want I can just okay, I think it's a real-time hands-on demo. Instead of going for simulation, this will be a better one, because compared to simulation, a real-time adds more value. See, I'm going to share this hand dynamometer value to cloud. Okay. At the same time, we know that we have LED, right? So that LED also can be turned on and turned off by sharing the information from cloud to LabVIEW. Okay, that logic will develop later. So initially, we'll try to push the data to cloud now. We'll see what are the functions we have to use in order to push the data to Firebase cloud. Okay. Fine. So we are using which protocol? We are going to use HTTP protocol, which is called Hypertext Transfer Protocol. You people are very good in the theoretical concepts. I'm going to directly show a hands-on demo. Okay. So you can just see here we have an option called connectivity, data communication. Sorry. So where we have different data communication palette. Okay. So where we have different options. Okay, see there's an option called protocol, so I can use SMTP protocol to send the information to mail. Okay, so through LabVIEW, if you want to send a mail, you can go for SMTP protocol. See, we have TCP protocol, we have UDP to have a file transfer, FTP protocol. Now we'll be using this HTTP protocol to transfer the data from LabVIEW to cloud over there. Okay, let me select the HTTP protocol. These are the functions which we will use to share the information from LabVIEW to cloud. Okay, so let me use an option called open handle function first. So this is a function which is going to create a reference for us, and it's going to open a session, and there is a shortcut called control H which will give you the help information about the respective function. If you doesn't know what exactly the function does, select and press control H. This will tell you the information. See, it opens a client handle, okay, right? And you can just make use of it to create a reference, and to push the data to cloud we'll be using a function called put data. Okay, so this is put vi, and if you press control H, see, it's going to send a web request and it submits to the file to the server, where we are going to publish the data from LabVIEW to the cloud over there. And here you need to specify the URL, and buffer is a place where you're going to give the information which we want to push it to cloud. And the last one is going to be close handle function, which I'm going to place it in the outside of the loop. Why I'm keeping open and close at the outside of the loop? Because for each and every time when I keep it inside, for each and every iteration, it opens the reference, it writes the data, it closes the reference. So instead of doing this continuously, it consumes more memory. So in order to avoid that, okay, I just kept all these functions outside. Okay, fine. And now I need to wire, okay, the open handle and the close handle here. And the most important thing here is it will accept. Okay, you can see the wire, the input wire control H. It accepts in terms of pink color. Pink color corresponds to string, but here, okay, it will accept what? It will accept JSON string. Okay, it will accept JSON string. It doesn't accept a normal string. So next step is what we need to convert. Okay, we need to convert this normal string data to JSON string. So what we can do is go to the block diagram. There is a palette called string palette. In string palette, you can see we have an option called flatten and unflatten string. So in this, there is a function called toJSON. Okay, I repeat, in string palette, number and convert, flatten and unflatten string, we'll be using toJSON. Okay, when I use this function, it will convert your other data type into JavaScript object notation into JSON string. Okay, so I'll be using this one, and this will always accept input as cluster. Okay, so maybe I'll connect this here. Okay, this will always accept input as cluster. That's why they mentioned this term as anything. Okay, to convert your other data type to cluster programmatically, we need to use a function called bundle function. So that is available in cluster palette. Bundle, you can just place it here. The function name is called bundle, which will programmatically convert your other data type to cluster. So we are going to put this information to the cloud. Okay, and you can connect it here. Your program is ready to push the data to cloud. The only thing is you need to copy the URL of the cloud, and then you need to put it here. That URL you should get from Google Firebase Cloud. So the programming part is over. Next part is what? We are moving into Google Firebase Cloud. Okay, so I can just go to browser. Okay, open a new window, Google Firebase. Okay, type Google Firebase, will get this option, Firebase Google. Same, by using a normal Gmail account, you can sign in here. I already have signed in, that's why it is showing my image here. Okay, you can just use this Firebase Cloud. It is free to have a data transfer. See, there's an option called Go to Console. Select this option called Go to Console. Okay, and initially you need to create a project. Okay, in order to have a data transfer, the first thing is what? You need to create a project. I have created some multiple projects here. Okay, so let me create a new project. You can just look here. There is an option called Add Project. Okay, just click on the Add Project. Fine. So it's loading. Okay, let me go for Add Project. Okay, and here you have to give a project name. Don't give any space. Okay, without space you need to enter. So Rio demo or else IoT cloud. Okay, and then click on continue, and then you need to select the analytics. Make sure this option should be enabled. Enable Google Analytics for this project, and then click on continue. Okay, so once you click on continue, right, and see there is an option called configure Google Analytics. You have to select it. You can just select default account for Firebase. It will automatically select the Google Analytics. Select create project. Okay, see now it is creating a project. Okay, so now your project is created, and just you can go for continue. Okay, so now you can see your project is created. Next we have to go for creating a real-time database. Okay, you can see left hand side we have category, right? Select real-time database. Okay, so once you select this real-time database, you can see here you get this option. So here you can go for create database. Okay, and let it be, you don't need to change any database location. Next, see security rules, let it be in test mode. You don't need to make it as locked mode. Okay, enable. I'm explaining each and every steps properly. If you want to use it, you can use it for your small application development, which you can do it in a system itself. Now I'm using hardware, so for your hardware is not required. Okay, and see this is the project name which I get, and you have to add a child here. Just add a child. Okay, you can give sensor value. Okay, and it's going to give in terms of string, and you can just give add. Okay, it's added now, and then click on this option, and you need to copy this link. This is the URL which we need to post here. Okay, you can just put the URL here. Okay, so let the verify server be false, and the most important thing, extension should be .json. Okay, so this should be the extension, and you can run the code. So it's going to be Firebase. It's deploying now, and it's going to push the data. Okay, the data whatever we pushed here, it will be available in the cloud. You can just click here. So we have to get the data. So let me copy the URL. I'll just go to the VI. And start the code now. .json. I'll put here. Save the values. So this is a place where we have to get the data over there. Okay, I'll do one thing. Let it be here. So I think it is not verifying the server. Just give this to check now. Okay, so I'll try to push the data to cloud. Just a moment. What I'll do is, I think there is some library issue, but still I can push the data to cloud. So I'll try to create a VI here. Instead, I can just pass it to my shared variable to the cloud also. I'll do it now. I think it is facing some problem. Okay, so this entire logic, I'll just put it in the another VI. I'll place it now. Okay. So what I'm going to do is, I'm going to push the data from my view to computer because there is a library issue. I need to rectify it. So it takes some time. So, but I want to complete the demo properly. So what I'm going to do is, let me introduce another shared variable. Okay. Or else I can make use of the hand dynamometer variable itself. Okay. Okay. So hand dynamometer. So this value, which I'll get from my sensor, I'm going to push it here so that we can read the data. I'll copy the URL and it's going to be .json. Okay, and then this is my code and where this is not required, and I'll be pushing the data to my hand dynamometer. See, what I'm going to do here is I'm pushing the data from Rio to shared variable. So from Rio, I'm going to share the data to my system, and from there, I'm going to get the data. Oh my God. So there is a power issue in my location. So the power has been gone. So the code is not deploying right now. Extremely sorry for the inconvenience. So no problem. I'll try to generate some data and then I'll push it in the cloud. What is the VI? It's here. Okay. So as there is no power in my place, so I cannot run my Mario because it is an electronic device. So what I'll do is I'll try to generate a number. Okay, instead of sensor, if I don't have a sensor, I can generate a number. Okay, I'll push this into cloud now. I'll run this. Okay, so then I'll just see whatever the data I am pushing it in the cloud with this generated number. That number will be displayed over here. And even if you have doubt whether the number displayed both are same, I'm going to create an indicator here. So sorry for the inconvenience. So due to the power, I cannot complete the demo with the Rio hardware. So maybe before the session completes, if the power comes, it will be very helpful for me. Yeah. So this is the VI. Yes. You can just verify. these two. See, whatever the data I'm getting here to the cloud, the same data, whatever the data I'm just getting in the lab view, the same data I'm pushing in the Google Firebase cloud. Okay, and you can look here, the Rio, it doesn't have power. There is a power cut in this area, so the device cannot work. So that's why directly I just generated some value programmatically using LabVIEW function, and then I have pushed the data. And you can see here, still it is updating the data in the cloud because I'm just running the system code in my system here. That's why we can access the Firebase cloud. Okay, so this is how you can make use of Google Firebase cloud to push the data from LabVIEW to cloud. So we have same option where you can just push the data from cloud to LabVIEW also. So that is also possible. Instead of put vi, we have to use a function called get vi and another logic so that we can receive the data. Okay, so with this, the hands-on demo for IoT-based application is over. Okay, so where we have used how thank God at least we had a power so that I can have a data transfer with my Rio and mobile phone. If the power has gone at that time, so there is no option to show a real-time hands-on demo. So that we have completed successfully. I think we got the power. Uh, Give me 2 minutes. I think the Rio is getting powered. If I run the code, I can show the hand dynamometer value itself here. So 2 minutes, please. Thank you. The Rio is getting power now. So let me give the connection. Yeah, the Rio is connected now. Okay. Let me run this hand dynamometer code. Fine. And you can see this VA also I need to run. Rio code. Yeah, this one also, so that we will get the data in the cloud now. Okay, see now it is showing 0.15. Okay, now when I just increase, you can see it is giving 10, 12, whatever the kg of force I'm applying there. So I'll take it, I'll hold it. See, you can give 15, 16, 17. So the real time data. So even if you have doubt, you can look into the camera now. Rio got powered and I am applying the force here. Okay, so we can see this data in the cloud. Okay, this is how you can just push your real-time data to cloud. So thank God, finally we got the power and I have just completed the hands-on demo. So with this, the demonstration is over. Okay, so if you have any queries, please let me know. So this is the contact information which I have just displayed on the screen. So if you have any queries regarding NI technology, feel free to ask. Any queries, sir? Any queries,
If participant
participant?
has any query, they can ask.
So for the given duration, so how much possible I can share? I have just shared the informations. So please let me know if you have any queries. So even I can just put my email ID in the chat box. Sorry. That's my email ID.
Thank you, sir. Thank you for sharing your email ID, sir.
Okay.
Thank you, Nagarajan, sir, for such a wonderful hands-on session.
Thank you,
Sir,
sir. I
science
have
is all
shared my
about.
mobile number also. You can make
Yes,
use
sir.
of it.
Yes, sir. We will share this with our participant.
Yeah. And
Yes.
participants, I would like to thank the institution as well as all you people for attending this FTP. So with this, maybe I just share few of the industry knowledge, whatever we used to do for the real-time applications to you people. I think this
Yes,
have
sir.
kindled a small interest to you to work on the platform. So you can just make your students also to work on it. And we provide, we are supporting to a lot of academic institutions on conducting FTPs and workshops. And we are supporting internship programs also. And we are offering some online internship programs on IoT, machine learning, deep learning, and for electrical people on electrical vehicles and all. If you participants wish to make your students to work on such kind of internships, you can just give my number to reach me. And we are planning some free technical talk for students also, maybe on 13th August. Okay, so if possible, I would share the information because there is a separate link over there. I'll share the registration form in the Google Form chat. Okay, so you can
Yes,
just
sir.
share the information to students also. If they wish to like
Yes, sir.
to participate on the industrial talk for students, maybe they can make use of it. Okay, so
Thank you, sir. Thank you.
give me a minute. I'll just post the link also. Maybe you can just
Yes,
share it for the
definitely.
students so that it's a free technical talk only where students will come to know about the NI technology. So, and if there is any query, please let me know. And if you have NI hardwares in your institutions, kindly work on it. So, I need to get the link. Just a minute. Yeah, I got the link now. So, this is the link for the Google form. We can just share to the students. If they register and join, they can attend the online technical talk on LabVIEW. So, thank
Yes,
you,
sir.
participants. Thank you, sir.
Thank you, sir. Thank you. On behalf of Government Women Engineering College family and workshop stakeholder, I like to thanks you and pray Almighty that we should hear more such sessions from you in the future, sir. Thank you. Thank you
Thank you.
for coming, sir.
Thank you, sir.
Thank you,
Thank you
sir.
so much. So, thank you, participants. Thank you.
Thank you, sir. Dear participant, next session will be as per the scheduled timetable. Thank you.